Welcome back to SOAR class, boys and girls. I'm Miss Vukmanic. So while I'm teaching, I can't even see you guys. So I will answer all questions after I do my lesson. And then if you want to stay and chat for a little bit afterwards, we can do that too, okay? Thank you so much for coming. I'm super excited to see you guys again. So today we are going to talk about science and the scientific method. We're going to do a simple experiment together and do a little observation, okay? So let's get started with our book for today is Ada Twist, Scientist. And this looks pretty familiar to another book you might have read. Before we start reading though, when we think of scientists, we often think of what they wear, right? We think of a cool, get this off, a cool lab coat, some goggles. I'm looking like a scientist now, right? Do I have to wear this to be a scientist? Do scientists need to wear these things? No, not at all. I'm going to wear my goggles if I'm doing an experiment that could be dangerous to my eyes because they're for protection. I'm going to wear a lab coat if I could get messy. I could ruin my clothes. Something's going to explode or something's going to get on me. So these are for more protection, but I don't have to wear these things to be a scientist. I'm pretty sure most of us are not wearing these things right now, and we're all scientists because scientists are just curious people who want to find out why things happen or how things happen. All right, so let's start with our book, Ada Twist, Scientist. And this is by Andrea Beatty, illustrated by David Roberts. I'll scoot this up so hopefully you can see. All right. Ada Marie, said not a word till the day she turned 3. She bounced in her crib and looked all around, observing the world, but not making a sound. She learned how to climb and made her big break with a trail of chaos left in her wake. She ran through the day chasing each sound in sight and didn't slow down till she conked out at night. Look at her falling asleep on top of the dresser. Her parents were frazzled but tried not to freak as Ada grew bigger and still did not speak. Clearly, young Ada, with lots in her head, would have something to say when it ought to be said. That's just what happened when Ada turned 3. She tore through the house on a fact-finding spree and climbed up the clock just as high as she could. Her parents yelled, "Stop!" as all good parents would. Ada's chin quivered, but she did not cry. She took a deep breath and she simply asked, "Why? Why does it tick and why does it talk? Why don't we call it a granddaughter clock? Why are there pointy things stuck to a rose? And what are those hairs stuck up inside of your nose?" She started with why and then what, how, and when. By bedtime, she came back to why once again. She drifted to sleep as her dazed parents smiled at the curious thoughts of their curious child, who wanted to know what the world was about. They kissed her and whispered, "You'll figure it out." Her parents kept up with their high-flying kid, whose questions and chaos both grew as she did. Even Miss Greer found her hands were quite full when young Ada's chaos wreaked havoc at school. But this much was clear about Miss Ada Twist. She had all the traits of a great scientist. Now, I might want to wear a lab coat for this messy experiment. Ada was busy that first day of spring, testing the sounds that make mockingbirds sing, when a horrible stench whacked her right in the nose, a pungent aroma that curled up her toes. "Zowie," said Ada, which got her to thinking, what is the source of that terrible stinking? How does a nose know there's something to smell? And does it still stink if there's no nose to tell? She rattled off questions and tapped on her chin. She'd start at the start where she ought to begin. A mystery, a riddle, a puzzle, a quest. This was the moment that Ada loved best. Ada did research to learn all she could of smelling and smells, both the stinky and good. One hypothesis Ada thought could be true. The terrible stink came from Dad's cabbage stew. She tested and tested, but soon Ada knew it was time to come up with hypothesis 2. And zowie! The stink struck again just like that. Hypothesis 2, it's caused by the cat. The cat couldn't make such a stink on its own. It needed perfume and some fancy cologne. So young Ada tested. The test was a flop. She started again, but her parents yelled, "Stop! Now never, ever, ever put your dog or cat or brother or sister or goldfish or any living creature in the washer or dryer." Ada Marie, to the thinking chair now by the time we count 3. "Enough," said her mother. "That's it," said her dad. Her parents were frustrated, frazzled, and mad. "Why?" Ada questioned. Her mother said, "No." "What?" Ada queried. Her father said, "Go. You've ruined our supper. You've made the cat stink. Enough with your questions. Now sit there and think." She looked at her parents. Her heart turned to goo. Poor Ada Twist didn't know what to do. She sat all alone by herself in the hall, and Ada once more could say nothing at all. And so Ada sat, and she sat, and she sat, and she thought about science, the stew, and the cat, and how her experiments made such a big mess. Does it have to be so? Is that part of success? Are messes a problem? And while she was thinking, what was the source of that terrible stinking? Ada Marie did what scientists do. She asked a small question, and then she asked 2. And each of those questions led to 3 questions more. And some of those questions resulted in 4. As Ada got thinking, she really dug in. She scribbled her questions and tapped on her chin. She started at why, and then what, how, and when. And at the end of the hall, she reached why once again. Oh my goodness. Look at that. Her parents calmed down and they came back to talk. They looked at the hallway and just had to gawk. No patch of bare paint could be seen on the wall. The thinking chair now was the great thinking hall. They watched their young daughter and sighed as they did. What would they do with this curious kid who wanted to know what the world was about? They smiled and whispered, "We'll figure it out." And that's what they did, because that's what you do when your kid has a passion and heart that is true. They remade their world. Now they're all in the act of helping young Ada sort fiction from fact. She asked lots of questions. How could she resist? It's all in the heart of a young scientist. And as for that smell, what can Ada Twist do but learn all she can with her friends in grade 2? Will they discover the stink that curls toes? Well, that is the question. And someday, who knows? Now, you might have noticed some of her classmates. You know who this is right here? That's Rosie Revere, engineer. And you might have read his book too. That's Iggy Peck, the architect. So those are some other characters from this author's book. All right, so Ada is just curious. She wants to know why things happen. And that's what a scientist does. And scientists use something called the scientific method, which is just some steps in a process to figure out things. So scientists start with, oh no, my things are out of order. They start with a question. You always need to ask a question first, and then you form a hypothesis. And a hypothesis is just your guess. What do you think is going to happen? You do your experiment, you collect your data or information, you analyze it or think about it, and then you can share it. And sometimes it doesn't work out and you start all over again with your question and you form a new hypothesis. Like it wasn't her dad's cabbage stew, so she thought maybe it was the cat, so she started over again. All right, we are going to do a very simple experiment today. With something that you hopefully all have at home. So what you're going to need is just a sheet of paper and something to write with. It can be a pencil, it can be a crayon or whatever. All right. You guys ready? You have a piece of paper and something to write with? Okay, awesome. Okay, and I will answer questions at the end. Miranda, do you need something, hon? No, you're just, okay, you're ready? All right. My question for today's experiment is, how many times can I fold this piece of paper in half? So if I fold it in half, how many times can I do that? So what I want you to do, our next step is to form a hypothesis. So I want you on your paper to write how many times you think this piece of paper can be folded in half. Okay, so go ahead and write it down. And I'm going to have you hold it up in just a second. All right, when you have your hypothesis, can you guys hold it up to the screen so that I can see them? And I'm going to write down some that I see, some different ones. All right, I see 6, 10, 7. Switch between screens here. Hold it up when you have it. I see 12, I see 36, I see 9. You can put it down after I've written down your prediction. I see 20, 15, 13, 5. Let's see what else. I see 11. I see 4. All right. Those are some pretty good predictions. I see 6. Thanks, Hunter. Okay. 5, 2. All right. If I did not get your prediction, I apologize. Oh, 90. All right. Now I want you to take that piece of paper. You can use the same piece of paper you just wrote on. And we're going to do it. If you don't have a piece of paper, that's okay. You can just watch me. Okay. All right. Will, that's a big number. All right, here we go. Let's fold it in half. Help me count. That is 1. I'm gonna fold it in half again. That's 2. Fold it in half again. And that's 3. It's getting small. Fold it in half again. And that's 4. Let's see if we can go again. Can you get yours? I got mine to 5. Fold it again. Ooh, it's getting harder. Use those muscles. Okay, I've got 6. Oh, I'm not sure I can fold it again. Can anybody get it a 7th time? Ooh, hurts my fingers. All right, let's see. Ooh, ooh, can that count? No? Some people say yes, some people say no. All right, so can we fairly say that we can fold a piece of paper between 6 and 7 times? Does that work? Did everybody get it about 6 or 7? Okay, so I'm gonna write down 6 to 7. If you didn't get it, that's okay. You can try it with another piece of paper later. So we collected our data. I was able to get a regular piece of paper, fold it in half 6 or 7 times. Now, is this every single piece of paper will be folded 6 or 7 times? I have no idea. We haven't done an experiment to figure that out. So I'm wondering, what if I have a big piece of paper? Will that be different? Let's see. I I have a huge sheet of paper here. I want you to think of a new prediction. So if you can just open your paper back up and write down, you can flip it over or write it somewhere else on the paper and circle it. What's your prediction for this piece of paper being folded in half? And then I want you to give me a second, and I'm going to have you hold that up so I can write down our new predictions. All right, I see 30, 100, 25, 37, 20, 120, 9. I got you, Carter. Is that 9? Okay. 10, 17, 50. Oh, Tatum, that looks like a really big number. I can't see it. 50, 40, 30. I think we've got 30 up here already. 1,000, Daryl. Let's see. 8, 13, 5. Devin, are you adding all those? 55? Okay. 55, 39, 11. All right. Let's see. A couple more. 1 million, Hunter. There's 1,000 and 1,000,000. All right. Let's give this a try. If I didn't get your prediction, I'm sorry, but just keep it in your mind what you think. Okay. And I know you don't have a giant piece of paper, so I'm going to fold it and you can help me count it. Okay. Here we go. Fold it in half. It's hard to get started. There's 1. 2. 3. It's getting small quick, isn't it? 4. 5. 6. 7. Oh, I'm trying. Using those muscles. Think we can count this? I see yes and no. All right, can we say between 7 and 8? Is that fair? All right, so a large piece of paper, we folded between 7 and 8 times. There's still a lot of space here to fold, but I'm not strong enough. It's too thick, so it won't fold anymore. Huh. Interesting. So this one could be folded between 6 and 7 times, and this one between 7 and 8. And the size of them was really different. What would happen if I had a small piece of paper? Would that make a difference? What if I have a teeny tiny little Post-it note? Is that going to change? Can you make a new prediction? Hold it up for me. Let me erase these. All right, let's see what we have. I see 2, 5. I see 6 and 10, 4. Where else? 1. It is a pretty small paper. 3. 4, 7. 2. I don't see anybody with 1,000,000 this time, or 1,000 or 100. I wonder why. All right, you ready to give it a try? Can you help me count them? All right, here we go. It's already teeny tiny. Here is 1 and 2 and 3, 4. It's really small. Ooh, you can get 5. I can get 6. I got this folded 6 times. Can you see how tiny this is? I just don't have any more room to fold it more. How crazy is it that a regular piece of paper can be folded 6 or 7 times, and a big piece of paper can be folded 7 or 8 times, and a small piece of paper we got 6 times. They're all really similar. Now, I don't have any more paper to fold today, but it does make me wonder, what if I had a piece of paper like the size of the school? How many times could that be folded? Or what if I had a piece of paper that was really thick like cardstock, or really thin like tissue paper that you put in a gift bag? What if I got a little square of toilet paper? How many times could you fold that? So scientists go through this process, but you don't stop after that. You keep thinking and you keep asking more questions. So you guys can keep trying to experiment and see if you have a tissue to blow your nose with. How many times can that fold in half? Or a piece of toilet paper, or a paper towel, or anything you can find in your house, and see if it changes the amount, or if it's always going to be 6, 7, 8 times. Pretty interesting. All right, we're going to do one more thing real quick, and then I see some hands, so I will answer your questions and stay and talk. But what I want you to do is, if you have another piece of paper, you can grab that. And if you don't, you can flip it over. And if you don't have paper at all, you can just think about this in your head. Scientists observe. They want to know what's going on in the world around them. So I want you to look at something that you've been looking at since the day you were born, and you probably don't pay much attention to it. Your hand. I want everybody to look at your hand. I want you to look closely at your hand. Look at the front and the back. Bend it and see how it moves. And then I want you to think about it and see if you can come up with any questions. Like, I'm wondering, why is my thumb down here and not up here with the rest of my fingers? Why, when your nails grow, is the tip kind of whiter, like it's a brighter color than the skin colored that the rest of your nails are? And where do those nails come from? My knuckles, why do they stretch when I bend them? Why are there so many wrinkles on my hand? So I want you to just take a couple minutes and look at it. And what you can do is you can take it on a piece of paper and you can trace around your hand. I'm going to try to do it up here so you can see me. It doesn't have to be perfect. And you can fill your paper with questions. Why does this happen? What is that part? And you can even draw in the details, like try to draw your fingernails and all the, I can see veins in here. Why? You can pick the back of your hand or the bottom of your hand and just explore it a little bit, just like you can explore anything in the world around you, because that's what scientists do, okay? So if you want to take a little time or a lot of time to do this, it's up to you. Tomorrow, when you come back, we are going to start talking about outer space. And we're going to start with those big balls in the sky called planets. We're going to talk about those. And then we will be moving on to stars, okay? So tomorrow, I want you to bring some paper, pencil, crayons, whatever you have, and we will do that. And we'll tie some science in along with it too, okay? All right, so thank you so much for coming, you guys. Stay on if you have questions and I will get to you, okay? And I will see you guys tomorrow. All right, bye-bye.